Hi, everybody. Welcome. Thank you. I'm Ron Pantafaro. I'm a solutions architect for Google Cloud. I'm a lead for our databases team. With me tonight, we have David right there, who's a product manager for Cloud Bigtable, and Daniel, who's a developer advocate. So a little bit of what we're going to do today. I'm going to kick us off with a little bit about GCP. It's going to be like 3 minutes, a little fluffy. Bear with me. Then we're going to dive into native databases, cloud native databases. David's going to talk a little bit about that, and then Daniel's going to take us into Bigtable. So, a little bit about GCP. Anybody here ever used GCP? Okay. So, why GCP? Because you get the best that Google can give you. Great marketing slide. And that's where you ask, but I'm not Google. Perhaps that's true, but hear me out. So let's talk a little bit about infrastructure. This is where we have regions across the world right now. These are edge points of presence. What that means is that these are locations that traffic can hit Google's dedicated network, which means we own all these fiber channels that are reserved only for our network traffic all across the world. So you can see that the regions are interconnected. So if you know from other cloud providers, you don't need to set up all sorts of IPsec or tunneling. It's just all within the same VPC, and it just works.
Switch my.
Yeah, or it's just me.
It sounds better. I don't know.
Let's see. Yeah, I think it's not. Okay, it's not me. So a little bit about the network. If you have some other cloud provider, you send some traffic. It goes underground or underwater. It goes with some ISP, then goes on some other channel and gets to your cloud provider. And with Google, you get to the ISP. From there, it goes to that edge point that we talked about it just a minute ago, and from there it goes even across the globe in Google's network. Another fun marketing slide, but I want to talk about preemptible VMs. Who is familiar with spot instances on AWS? Okay. So spot instances, or here preemptible VMs, are excess compute capacity that you can get for up to 80% off, except you don't have the bidding war. We give flat rate 80% off for the duration of that VM, which can be up to 24 hours. This picture of Chateau Chambord makes me happy because I proposed to my wife just a few miles from there. I did not pick this out. I did not choose this one. But so that's security, and that's security in practice. And my point is that you basically get everything that Google has to offer when it comes to security, storage, networking, hardware, our operations, and everything else in all layers comes baked in. And another thing I'm being asked about all the time, and I can't emphasize this enough, we don't look at your data, we don't analyze the data, we don't use it for marketing, we don't use it for anything.
Just like email.
Yeah. I don't think that the fine print on Gmail might say that. Here the fine print will say that we do not do anything with your data. It's yours. We don't have any backdoors. We don't have anything. It's encrypted in transit and in rest. It's all yours.
You own the encryption key though, right?
You can.
I can?
You can provide your own encryption keys. Yes. And final slide is that we're using 100% renewable energy since 2017. And just another minute about data. This is going to be a big slide. Wait for it. Okay. So everything here is basically databases, and I'm not going to talk about this because we're going to talk about it in a minute. So that's where you store everything, for database purposes. For data analytics is more or less everything to the right. And what I like about it is that we have a complete suite of products from ingestion to analysis to ML and visualization. And many of these products are completely serverless. You don't touch the infrastructure. You don't need to manage it. Data flow is a data pipeline that is completely serverless. BigQuery is a serverless data warehouse. And when it comes to ML, anybody here from ML, AI? Okay. So whether you know zero about ML or AI, or you're a world expert, we can give you the right products or the right tools. You can just call an API and get your videos tagged, or you can write your own models, and you can leverage tensor processing units, which are chips designed by Google to perform machine learning operations faster. And for David.
Thanks, John. So you guys just heard a little bit about what makes Google Cloud unique from a networking perspective, from a security perspective, and in particular from a data analytics, ML, and AI standpoint. So now I'm just going to take a couple minutes and tell you guys a little bit about our cloud database offerings. And Daniel Bergqvist, who's around here somewhere, is going to provide a couple demos for 3 databases in particular. So without any further ado, let's dig in. Google Cloud Databases. So maybe Google isn't necessarily the first name that comes to mind when you think about databases, or at least perhaps that wasn't the case a couple years ago. But the fact of the matter is that Google has 8 different products available globally, highly performant, with all the features that folks expect to receive. And in order for us to achieve this kind of scale and do so in a very reliable, highly available manner, we've had to invest very substantially in the underlying infrastructure that supports it. So I'd say kind of the combination of those investments, those ongoing investments in infrastructure, and the culture that we have of continuous improvement help to really set us apart with respect to the databases that we now offer to the market. We have solid 20 years of experience in doing what I like to call creating and solving big data problems. So way back in 2002, 2003, we ran into a bunch of problems, big data problems that we ended up solving in the form of our original Google file storage system and MapReduce, which over the years helped shape the Hadoop ecosystem. Fast forward to 2019, and Google's contributions to the AI and ML space are similarly interesting in terms of scope. With respect to our database portfolio, this is kind of a big slide. I won't spend a ton of time on it, but would mention that in addition to the databases that we've built and that we manage on your behalf, if you have to be a Google Cloud customer, we also offer partnerships with folks like Redis, folks like MongoDB to cover use cases that perhaps our native databases, our build and managed databases, can't quite cover just yet.
What's the difference between Bigtable and BigQuery?
Good question. So Bigtable and BigQuery are actually really different, notwithstanding the word big in front of them. That's kind of the common thing. We like to do things that are big at Google, and the word big ends up all over the place, actually. So Bigtable fundamentally is basically a wide column store. It is a database that's pretty well suited for both operational and analytical workloads. BigQuery, by contrast, is a data warehousing tool that is, for the most part, I would say, intended for analysts who are running ad hoc queries. So very, very, very different user, very different use case. They happen to play really nicely together, but they are quite different in a lot of important respects. Does that answer your question?
So BigQuery supports SQL?
Yes, it does. Yes, BigQuery has a SQL interface. Really, really popular with analysts to write ad hoc queries. Tends to be really, really quick, very responsive. Awesome product. I used it at my last job, so I can definitely attest to how great it is. So just for tonight, though, we're going to spend a couple minutes talking about 3 databases in particular. One called Cloud Firestore. If you haven't been familiar with it, great. If not, I'll give you a few details about it. Cloud Bigtable, although Daniel is actually going to be the main event, he's going to be telling you a little bit about it in detail, I should say, later on. And Cloudspinner, which is a really interesting database. that we'll get to in just a sec here. Cloud Firestore is a database that is something that makes it really simple and easy for you to store and sync and query data for mobile and web applications in particular. Internet of Things also, but really for mobile and web. It's really, really good choice for helping you to get an app out the door and make it available to users globally with very little lift required on your part. So quick overview, Firebase provides the authentication, security rules, cloud function, hosting, what you might call sort of the middleware in between an SDK from Firebase. Anybody familiar with Firebase by any chance?
Firestore or is it Firebase?
Yeah, there's Firebase, which is basically a set of tools that are available to mobile developers in particular, and Firestore is the underlying database that supports it. So for folks who are working at startups or perhaps working at large enterprises and looking to get a prototype out the door really quickly, Firestore and Firebase are a great combination to help you really ship something quick, get it out there, make it available globally in very short term with very low lift required on your part.
Can you have like a offline store on your mobile device? With
Yeah, actually, as a matter of fact, sure, can get to that in just a second. So Firestore is serverless, fully managed. It's a document database. Tends to be quite well suited for semi-structured data like JSON. It also, you could argue, and we do argue from time to time, is a backend as a service. It's sort of like something that is a little bit more than just a database. It's sort of like a backend that is available to, again, especially your mobile apps, to enable really easy integrations and, again, get something out the door really quickly. And in a sense, it's an embedded database also, especially given the way that it caches your app data to support writes, reads, listening, and data queries, especially if you're thinking about a mobile app and that user is offline for whatever reason on the subway in a region where connectivity is a little shoddy. Firebase is great for helping to support some operations while that device is offline because of the way it's cached and behaves.
Can it encrypt those data also that cached?
Yeah, I believe so. I'm the PM of Bigtable, not of Firestore, so I'm not sure offhand how encryption works on Firestore.
Very important, right? Because the offline data needs to be secure.
Yeah, so that's a good question. I would think it's encrypted because it remains,
What was that question?
The question is about encryption for data on Firestore in the case where you've lost network connectivity. Or I should say that the native app has lost network connectivity. Yeah, we can follow up. That's a good question.
It's encrypted. Data that is sent is encrypted. Data in transit is encrypted as well.
But when you say an embedded database, it means it's embedded like in the car or in the device.
Yeah.
And there's no cloud. You're saying that's just like a, I don't know, buffer, or
Again, I'm not an expert on how the caching works in Firestore. Yeah. So it's unusual in a lot of different respects. Feel free to check out our website, but I'd be happy to follow up with you after this is over to get those details for you. And Daniel has a demo that he's going to provide for Firestore.
Yes.
Daniel Bergqvist, our developer.
Thank you. I probably can't use the mic because then I can't type. So hopefully you hear me anyway. Okay, so what we have here, we built a demo that simulates devices, mobile devices. So each pixel in this picture is a device. So this is the demo app, and this is the Firestore database. So as David mentioned, Firestore is a document database. So here we have four input documents that corresponds to these different colors. So there's 2,500 pixels in each document. And then you have these devices over here that listens to the inputs. And every time you change something in the inputs, the devices will pick it up. It's a Golang app that runs on GKE, and it will propagate them to the display app. So if I go in now and I change the the value here to blue, for instance. Wait. Let's do like this first. Let's update this first so we know that everything is working. And then we update the red field to a blue field. And the devices picks up the change and they propagate the change to the pixels that. So this could be pretty similar to having an app, a gaming app where you synchronize stuff between different players in a multiplayer game, for instance. So this is super simple to build in Firestore. All this syncing, real-time sync mechanism is something that we brought from Firebase into Firestore. So Firebase is still around, but originally Firebase had another database that it was built on top of. So we took the best from Datastore, which was our document DB, and we combined it with the ease of use that we had in Firebase, and that's what Firestore is all about. Cool, thank you.
Yeah, questions here.
Yeah.
Yeah.
Sure.
To support offline mode and everything, I guess with the mobile, you have the client version of the database on the mobile device, and it will automatically sync with
When connectivity is restored, if that was what we were discussing previously.
Cool. Any other questions?
An answer. Firestore doesn't encrypt, so that automatically.
Sorry?
Oh, with respect to the earlier question, yes, Firestore does encrypt in the case that you mentioned.
Channel will, right, if you run as a TLS. It depends what you define encryption. Right, I mean, it's not going to be like an application when you encrypt the application, but you are building a secure channel. And let's say behind the scenes, it's encrypted. So that's what I mean.
Great, thanks for the clarification.
Is the data stored ultimately on GFS?
Sorry, can you repeat that?
Is the data stored on GFS ultimately?
No, the data is stored, I believe, on. Yeah, probably.
Firestore is built on top of Spanner, yes.
On top of Spanner.
Yeah.
There you have it.
Which
Thanks.
is on top of Colossus.
Yeah, so the underlying storage mechanism is Colossus, if you've heard of that, which is kind of our second generation file storage.
That's the Cloud DB.
Yes, that's right. Yeah, exactly. Thanks for the question. Switching gears to talk about Cloudspinner. Speaking of Cloudspinner, Cloudspinner is a really interesting database. It combines a lot of the characteristics of a NoSQL database, the scalability characteristics, availability characteristics in particular, with the kind of the best of a relational database, including strong consistency, SQL interface, and a couple of other things too. I'm not going to spend a ton of time on Spanner here, but what is unique about it really is those, the relational semantics that you might expect out of a SQL database with the horizontal scalability characteristics of a NoSQL database, including on the relational side, what you might expect to see is something like ACID compliance. Spanner is fully ACID compliant, yet it also is very highly available and very, very scalable. So it tends to be really, really well suited for apps like banking, apps like online retail, where consistency is extremely important, transactional consistency. And just speaking about those use cases, some of the most popular ones, or at least the ones that are probably most interesting to talk about here, are those mission critical applications where downtime is not an option. Black Friday is coming up, for instance. So if you're an online retailer who's concerned about availability, is concerned about earning the revenue that you'd hope to be able to earn on Black Friday, and ensure that you are maintaining transactional consistency, Spanner can be a really good choice, and indeed it is for a number of different online retailers. In terms of retail in particular, there are certainly some scalability and availability aspects that are leading folks in retail towards Spanner, And then additionally, online gaming. Daniel touched on online gaming. It's kind of an interesting and very challenging use case to support if you're building a database that's intended to be globally available and highly performant. So for instance, online gaming companies rely on Spanner to maintain state for millions of concurrent users. So high throughput, that global footprint where everybody is getting that same state across the sessions, across millions of different concurrent user sessions. These are some of the things that Cloudspinner can help enable. And now Daniel's got a quick Spanner demo that he's going to show off.
Sure.
Is it replicated across the regions?
Yes.
Yes.
Yeah, global replication.
Replicated, I mean, synchronous, you get an ACID transaction.
Wow.
Which is fairly unusual.
Yeah, it's not eventual consistency.
Replicated synchronously. So.
Yeah, that's good.
Replicated might not be the right.
And would that make transactions slow if you replicate it synchronously across, like, say, from New York to London or something?
So he uses Paxos as a. Well, let Daniel do your demo first, then.
Okay.
If you want.
So this is a super easy demo. I'm just going to show you how easy it is to set up a Spanner instance, to provision a Spanner instance with as many nodes as you want, create a schema, do some online schema changes, and that's about it. So we're in the...
Can you make the fonts a bit bigger?
Sure.
Thank you.
Cool. So, demo, we do like this because this has to be unique, I think. Like this, we do a regional setup and we put it in US East. And we do only one node in our cluster to start with. And we click create. And it's created already. And I have a cheat sheet here, so I don't have to write everything. And I'll create a database. And then I add a table and wait. There you go. So I use some DML here to create the table and my different columns and the data types for the different columns. Okay, there you go. We're up and running. Now we can go back to our instance and we can easily add more nodes, allocate more nodes to our let's say we want 10 instead. And the instance is updated.
So that does that
So
shard stable.
you don't have to think about the sharding. Spanner will take care of the sharding of your data. So you just provision nodes, and it's equivalent to how Bigtable works, like the balancing of data on different nodes.
Well, in Bigtable you need to like think what the row key is.
You have to put some thought into the row key in Spanner as well.
Yeah. So it's not really row keys, but your index and especially your secondary indices, which are interleaved in Spanner. Yeah.
Are the columns typed?
Yes.
So you mentioned earlier that you can only deploy Cloudspinner to, I think you said up to 3 regions, is that right?
Yes.
So what are typical topologies for like the various regions, and what impact do those have on the latency profile?
Okay. I mean, you hear me again?
Yeah.
Okay. Yes. There is obviously some price, but because we own all the infrastructure and all the network, and we have all sorts of how should I say, optimizations in place, then if you get something that you get an end product with performance that you would not get otherwise.
You have different configuration options. So you can say, look, I want to have Spanner running in 3 regions. That would be like Asia, America, and Europe. Like if you have a case, you still write out, your nodes are going to be in each of those regions, and you will have a leader in one of those regions for any given split of data. So basically, that leader will then coordinate the transaction using the Paxos consensus thing. And because, as Ron mentioned earlier, our network is global, and effectively we have multiple routes, we don't suffer, we have very small amount of network partitions. So we can guarantee strong consistency. Spanner will sacrifice everything for strong consistency. Like that's the #1 thing. So you can be sure any data that gets written in Spanner. What you can do for latency, for example, if you are using a global setup, you can have, and you have some reading, and you say, well, I can tolerate some like staleness in my data. You can do a bounded read, for example. But again, you know, like if your lead is in the US and you're writing from Europe, you will have the latency of a write to.
That's okay.
Just with that, is there an ability to then say take some piece of your data, some like prefix on your primary key, and say only put this in Asia and replicate it in Asia, but don't replicate that row or set of rows to Europe?
Each row belongs to a split.
Yeah.
Those like the data is going to be replicated in all the regions where you're running Spanner, but in that split will have, you will say where the lead is and which location the lead is. Typically that would be the US.
Okay, got it.
But actually, there's a related question I have, which is that there are a lot of countries that are now starting to come out with these data sovereignty laws. The data has to be kept within the countries. And so therefore, are you folks planning in Spanner to be able to say, look, I just want to have this data placed in this, you know, in this region or this country, and it can't go anyplace?
In Spanner, there are some, you have regional, you can deploy a regional matter or cross-regional, so you can definitely keep the data in.
But I'm saying in a global database. Now, let's say I have those 3 world regions. But let's say like Germany, for instance, you know, or China's probably the same. China is very specific about keeping data in China. So therefore, can I have this global database, but all the Chinese base of data stays, you know, let's say.
So as I said earlier, depending which configuration, if you choose for a global setup Spanner, you'll be running in all 3 regions. But you can also choose to run Spanner regionally, and then you're bound to that region. So all of our data products, all of our storage products, you have different options as to, you know, do I want this data to be available in multiple regions? Do I want to confine have it in one region? We even have, for example, with cloud storage that you can choose dual regions. So if you want a high availability and you want to be very specific on which 2 regions, so there are many different options around this.
I guess the question is like what kind of granularity you might have. Like maybe some piece of data you want to global and some piece of data you want like regional or something. Yeah. So within that Spanner database, can you like?
Then you have 2 databases.
Yeah. You need to have 2 databases. You cannot just configure different like tables differently in the same database. Right?
Yeah.
And speaking about
let's have one last question for now for Spanner, and then we'll move forward, please. And then we'll have more time for Q&A at the end.
Well, I actually have a question about infrastructure that you were showing there, all these fiber optic cables. Is it shared with all your products, YouTube?
Yeah.
It's all shared, right?
But so well, we can do stuff you can't do in a public network, right? So we can prioritize traffic and say that YouTube backups are less important than your user traffic, for instance.
Are there like levels of service level?
Yeah, all of the products have service level agreements. I'm not going to go through them all now, but as Ron pointed out, we own that network infrastructure, and we have multiple routes which we also run part of the internet traffic over that as well. So it depends.
Like ISP?
Sorry?
Like ISP, you mean?
ISPs have they can choose to run over us. They can choose to run.
Well, I'm saying, are you providing? You said you're providing internet service too. You're running internet traffic.
We provide networking for our own services, for our cloud customers, and also some of the internet the internet runs over our network as well.
We also have a premium. There's multiple service tiers at the
Cool. Okay, let's jump straight into Bigtable. You are super lucky tonight because not only am I here, but most of the Eng team from the Bigtable Eng team is also here. So. So don't hold back on questions. There's. Should I stand up now? Yeah, probably. I don't need it. So, what is Cloud Bigtable? It's a petabyte scale, fully managed NoSQL database service. It was support to write-heavy use cases where low latency is key. Okay, David, have you put this into mine?
No, this is mine.
Sorry. I thought it was.
Sorry about that. Just minor glitch. So I'm just going to run through a couple quick Cloud Bigtable slides here. Daniel's obviously very excited to give his part of the presentation, so I don't want to delay for too much longer. So Cloud Bigtable offers 4 key things: speed, low latency, great performance. Scalability characteristics are also, and especially, I neglected to mention throughput. Scalability characteristics are also quite strong. Bigtable, like Spanner, has been very, very widely used at Google for all kinds of products for many years. It's fully managed, so you don't have to worry about a lot of the operational headaches that you might if you were, for instance, running on-premise, I should say. And it has some nice integration options. So I'm going to skip over a couple of these slides so our friend Daniel can get going with his prezo. Long story short, high throughput, low latency use cases are the bread and butter for Cloud Bigtable. In terms of integrations, Bigtable has a bunch of integrations that are also very widely used. We play very nicely with the open source ecosystem, of course. We have an HBase compatible API. We have full wire compatibility. We offer streaming and batch processing integrations with supporting very popular frameworks like Storm, Spark, and additionally, there are a lot of very popular use cases that we come across among our customers for time series databases and graph databases, geospatial as well. And there actually is a lot of information about these on our website, so feel free to check those out if you've got a minute.
But it's not a graph database.
No, it's not a graph database per se, but the performance and scalability characteristics make it pretty well suited for covering a lot of those use cases quite well. For instance, Search and a couple of other products have used Bigtable for many years. In terms of integrations with other Google Cloud products, BigQuery certainly is a very popular data warehouse that we play nicely with. Dataproc, Cloud Dataproc is Google's hosted Hadoop and Spark product. If you happen to have heard of Dataproc, not a lot of people have, I don't think, who I've come across. Dataflow is basically very well suited for building pipelines and shipping data back and forth between various Google products, and a TensorFlow integration as well. Popular use cases, there are a whole host of use cases, of course, for many years that Bigtable is supported within Google and continues to do so. And then, of course, outside of Google, Bigtable is very popular for marketing tech and ad tech use cases, including where Bigtable is right in the middle of the serving path. So supporting things like ad targeting, personalized marketing, content, and product recommendations, very, very popular use cases for Bigtable. In terms of financial risk analysis, another popular interesting area, things like anomaly detection to help customers identify fraudulent activity, identify threats in real time, and help mitigate them, as well as some of the offline analysis, batch processing that's important for supporting those kinds of use cases behind the scenes. IoT also very popular. So if you have a factory and you have a whole bunch of different devices on your factory floor that you're monitoring, a lot of folks are monitoring those devices, which tend to have reasonably high failure rates. So detecting those failures and responding promptly. Definitely really kind of fun use case for us to follow.
It's essentially not reduced database, right?
No, not at all, no.
As far as, well, not the database, but as far as the batch processing that you're talking about.
So the question is about batch processing specifically, or? Yeah, sure. So folks use, the interesting thing about Bigtable is that it is very well suited for a very wide range of different use cases. We have customers who use it for very low latency, latency sensitive applications, latency sensitive workloads, where you need something like sub 10 millisecond response times. Some customers use it for batch processing, believe it or not, which is, I think, not probably the most popular use case, but is something that we have found customers have found a lot of success in doing. So, it's quite different than MapReduce, at least in terms of the way that it works. And actually, speaking of the way in which it works, Daniel's going to be providing a bunch of detail in just a minute. So feel free to ask more questions about Bigtable when he gives his preso, or the rest of the preso. So with that, I will hand things over to Daniel.
Thank you. Did you have a question?
Any use case that Bigtable handles really badly? Because usually there is, in any infrastructure you build, there is some sort of case that...
Anything where you need table scans is pretty bad.
Table scans?
Scans.
Full
Full
table scans.
table
That
scans.
means you have to look through the entire table
Yeah.
very quickly.
Yeah.
That it can't do very easily.
It can, but take some time.
Yeah.
Okay.
Not really meant for joins either.
No joins. No joins at all.
NoSQL database.
And we'll go into the nitty-gritty details of this. So first, you always have to have a pop cultural reference in every presentation, I think. So how many have seen Pulp Fiction?
I have a question.
And this is sad because I feel how old I am now, because less and less people have seen Pulp Fiction. But for those of you who have seen Pulp Fiction, you know that this is Harvey Keitel and he's Winston Wolfe. And when you have a problem, you call Winston Wolfe. And John Travolta calls Winston Wolfe, and he says that traffic in Los Angeles is bad, so that's 30 minutes away, I'll be there in 10. I think that's a little bit the same promise that Bigtable gives you. It's a managed service, so you have the Wolf taking care of everything for you. It's faster than most things on the market today. So if you only remember one thing tonight, remember the Wolf. That's Bigtable. So let's start by looking at one slide with client connectivity. So these clients, regular database clients or mobile apps or whatever they are, they connect to one single endpoint, which is this load balancing proxy. So regardless what happens behind this proxy, it's the same endpoint that they connect to.
Clients like what? Impala?
Sorry?
What kind of clients? Like
Whatever client you want to connect to Bigtable.
Impala SQL?
No, not that kind of client. But so.
I mean,
This could be an IoT, whatever.
Yeah, but by IoT, okay, it's
Yeah.
how it provides the data. Through what API?
Through
JDBC.
Yeah, JDBC. Is there a JDBC connector now? No, but we have an HBase API. We have a native Java API. We have client libraries for all the big languages that you can use. And under the hood, there's a REST API, so you could basically build your own client if you wanted to. But we provide client libraries for Java, Python, Go, PHP, Ruby. Yeah. So, but one endpoint, no rediscovery, whatever happens behind that endpoint. So that is still true, but I removed the proxy layer because otherwise it would be.
What's the significance of that proxy? I mean,
So you will see what the significance is when we go further. So here you can see that the clients, they connect to Bigtable nodes, but the Bigtable nodes themselves don't hold any data. So you could say that Bigtable is stateless, which is a pretty odd characteristic for a database, right? Bigtable stores all its data in our distributed file system, what was formerly known as GFS, and this is the successor Colossus.
Are these nodes replicated? Because you have pointers in them, right? Into Colossus.
Yes, we will come to that. So, the data access in this case. So, the different Bigtable nodes, they are basically custodians of key segments. So, in this case, the first node holds key segment A, B, and C. The second one holds key segment D, and the last one holds key segment E. And then if there's a lot of traffic for key A, then there is a risk of the first node becoming a hotspot. So what Bigtable then will do is that it will rebalance the data. So it will move C, for instance, to the second node. And this operation, since the nodes themselves don't hold any data, this is an online metadata operation that doesn't require any copying of data. So this is instant. And again, as you said, this proxy, since now this key segment is served from another node. That doesn't matter for the client. It's still the same endpoint.
So proxy is processing basically.
Exactly.
So basically, it sounds like you're sharding by the key domain, right? So,
yeah.
And then the Bigtable nodes are essentially load balancing the load themselves by themselves.
Good.
Okay.
Right. Yeah. So the nodes themselves are for throughput. So if you need more horsepower in serving more users, we say that each node roughly can hold or can give you roughly 10,000 QPS.
That's sharding processing, not the data. So
Yes.
How's that storage actually organized?
So we will come to that.
So in bandwidth space, what would that be? 10,000 QPS.
Oh, that's hard to say. I mean that.
What's the average size of the query in that statistic that you just
Well, that's very different. It totally depends on your access patterns. Like if you're doing point lookups or if you're doing like bulk reads or.
So let's say let's just make it easy. Let's say hash lookup like for a particular key. We're looking for a particular key.
Mm.
Like what would be the
So
statistic that you just quoted?
I don't know the average, but like we.
10,000 is 4K reads. 4K?
Yeah. And then we can get like 200 megs to 200 megs per second.
So 4K for the key itself, or is it?
Say the key alone. Yeah.
Okay.
Cool. So same thing happens then when you want to scale up or scale down your cluster. You resize your cluster, you add more nodes to your cluster. We will balance your data for you and take care of that.
Well, these nodes, are they like replicated like in HDFS, like 3?
I don't know how many disks data is written. So what happens is that you don't write to the Bigtable node first. First it writes to, I will come to that, but first you write the head log in Colossus. And then you write to a mem table in the Bigtable node. So if you lose a node, you can always replay the write ahead log to get back the data. And I don't know how many disks a write in Colossus are replicated to, but at least.
You know, imagine it being free.
Yeah, I think.
It uses resolve encoding, but imagine it's like being written.
I would say.
No more.
Yeah.
I'm curious to understand how did this Colossus actually organized, because as people were saying, if I have some German personal information protected. You know, it's gotta be in a certain place.
Yeah. So
and it has to be auditable, not just like.
So in this case, we're talking about an song. So, by the way, if you want Colossus, there is a paper. Right?
Yeah, there's no paper for Colossus. There's paper for GFS, but that's pretty close.
but like, so for like GRPS and stuff like that, or what is it called?
So imagine you have a region. That region will be made up of multiple availability zones. Each one of those zones is a thing unto itself. If you're running in a regional setup, then your data is going to be replicated across the zones in that region. If you're running in a multiple region setup for a different kind of product, your data will be replicated. But you choose that depending on the product and the setup.
I mean, if you don't want your data to leave a region, it won't.
But if I do, can Bigtable occupy more than one cluster?
Yes. We have replication. So you can replicate your data both within a region to different zones or globally between different regions.
But that's between clusters is replication.
Yes.
Yes.
So as we just said, the rule of thumb is 10,000 QPS, linear scalability. Yeah, so with replication, you get 3 nines in availability, the SLA. And if you set that up to be global, you get 4 nines, and you can have 4 replicated clusters right now. It's super simple. Replication, you can use it for high availability, or you can use it for workload separation. So let's say that you have 2 clusters, one that you serve end user data with, that is in the serving path, and then you have another cluster that is for your batch processing or whatever.
Is it consistent also?
Eventually consistent. You can set it up so it is consistent, but it comes with a lot of caveats then.
But there is no like load balancer that I can go in one place. And
yeah, you can do multi-cluster routing. Is that what we call it? I think so. Yeah, and so we will route it to whatever cluster is closest or whatever cluster that has most resources available.
So why would I use that instead of Spanner or something? Spanner is like consistent and it also can replicate it. It has like SQL interfaces. It's easier in or something. You know?
True, but if you want like single-digit latency in like the 99th percentile at scale, it's very hard to beat Bigtable on that. And also, if you don't need the relational semantics, for instance, let's say that you just have like monitoring data or IoT data, like whatever time series data you have coming in, it's a brilliant use case for Bigtable.
It's a key value store, so you can just.
Yeah. It's a key multi-value store.
The whole data is actually a table.
Yeah. But well, you can think of it.
JSON or documents or?
No. We'll come to that.
Okay.
So it's a distributed key multi-value store, I would say. So it supports atomic single row transactions, and it's a sparse database. So unwritten cells do not take up any space. And if you then want to, for instance, identify this column, you would go for the row key, the column family, and the column qualifier. So you don't have that many levers in Bigtable, so the row key design is super important.
It's kind of similar to Cassandra.
It is. It is very similar to Cassandra. So it has a 3-dimensional data space. So it has where the 3rd dimension is time. So each cell can have multiple versions, and you decide how many versions you want to store. If you want to store N versions, or if you want to set the time to live on the versions, and we will do the garbage collection for you.
So it's multi-temporal then. Well, there could be more than one.
Yeah. Tablets, it starts with one table, splits up in different tablets that holds different key segments, and that's what is then balanced on the different nodes. So, but if you have like a hotspot, you go down to you can go down to a row, but like you can't go much more.
These ABC things that you were showing, that's
Yeah.
what.
That's the key space. That's the key space. Yeah, exactly.
And they will end up in separate tablets.
Yes. So each tablet is exclusive to one node. That's the one who serves that tablet.
But on Colossus, it's all together.
So we come to this now. So, and you can say that like a write operation, as we talked about, is first written to a write-ahead log in Colossus, and then it's written to an in-memory table on the node itself. A read operation first checks for data in the in-memory table, and then it goes down to Colossus where everything is stored as sorted string tables. And then you have when the mem tables are flushed into Colossus, you have a minor compaction, and when the different levels of SS tables in Colossus are merged into one, that's the major compaction. And then we do a lot of smart things in order to find which SS tables to look into and not, Bloom filters and whatnot.
So what's faster, write or read?
Sorry?
Which one is faster, write or read?
Right.
Well, just because the read goes across huge amount of data.
Especially
just in the log.
Yeah. No, so
How many of those logs do you have for each tablet?
I have no idea. I don't know.
It's an interesting idea.
So it's probably good for like 10 series data or something like that.
Not a transaction log, but a pre-writing log.
The write-ahead log, you mean?
Yeah.
I don't know.
I'm not sure if you just answered this by using some form of multi-version concurrency control.
You mean for?
For consistency for ACID, yeah.
I don't know what consensus algorithm is used under the hood.
There's no asset. I mean,
No, there's no ACID transactions. Like it's. Well, that's also why you split tablets. Like you never split the row. Like if you look at BigQuery, which is a columnar store where you store different columns on different machines. Here you store the whole row because you need. I mean, if you start to split up that row, it's very hard to.
I guess I'm asking because you're doing the writes on the write-ahead log, which means that implies and then you're putting they're cached in memory until they're eventually compaction. So it sounds to me like during that process, for a while you have some current data and you'll have some previous versions of it. So that's why I was wondering if you were doing some sort of multi-version concurrency control there, or is it just, or is it not? Or is it consistency?
I'm not sure, but we don't give those guarantees at least.
Okay. If you're doing writing the same row, column, timestamp.
Yeah.
And you are in the middle of a write, so it takes 5 milliseconds.
Yeah.
And somewhere in the middle of 5 milliseconds, you do a read for a complete, so you read the stale data.
Yeah.
That's correct.
Yeah.
But if you write 2 writes with different timestamps, the same thing, then you won't have that conflict. They're treated separately.
Cool. Yes, and you already asked the last question, if it's optimized for like every like.
Wait, no, sorry, let me correct. It will lock.
It will lock.
It will lock. Yeah. So if a write starts, if a write is starting on that piece, and a read comes in, it will lock until that.
Okay.
So it tries to make sure you're not reading still data on a single cluster. Stillness happens with replication.
Across clusters, yeah. Cool. So I guess all databases that has some kind of LSM tree as a storage engine is optimized for writes. So a little bit about the API. The API is actually fairly simple. You can do gets, single point lookups, or you do short range scans. You can do more than short range scans, but that's slow. You can apply filters to your gets and your range scans, and you can do full table scans. On the other side, you can do put, increment, append, etc., etc. And all these are then exposed through the different client libraries that we provide. So I won't read this out to you, but it's the Bigtable API in some kind of pseudocode. And we also have it in SQL terms. And let's look at a Loft Demo.
There is no way to ensure that row key is going to be unique, is it?
Row keys they depend on you provide.
There's no way. Well, you're responsible for the row key. I mean, they are unique by definition. If you write to the same row key, you will overwrite data. Depending on what you're doing, because if you're using your Z index to have multiple versions, you'll write another version.
So if I'm providing you a unique key and using that key to create a row key, or whatever.
You have to define a row key, and the important thing is to ensure that it's not monotonic. So you choose a row key, like the more random the row key choice, the better, because this thing scales linearly. Yeah.
So that means the hashing is a good idea.
It scales horizontally. Is what I want to say. Sorry, mix up my word. But if it scales horizontally, and you have all of your row keys are sequential, and then you have a whole bunch of random reads that are all coming to those keys, then you will create a hotspot. But we have tooling for you to visualize this as well. So you can get some insights to find out, have I chosen a bad row key?
Or are my rows too big?
So if I did choose a bad row key, can I choose a different one? On the existing data entity.
So it's a key wide column database. So think both Cassandra and HBase are based off the Bigtable paper. If you're really interested in all the inner workings of Bigtable, I'd suggest reading that white paper. It's quite hefty, but it does go into all these details. But your row key, any row is identified by this key. So if you choose a bad row key, then you will have to, and you want to correct that, then you will have to choose another one, and you will write to that row key, and then you can go and clean up the old stuff.
So how would you construct a key if my data access patterns are actually ranged? So you just said that it needs to be random so that it's a load balance, but then, by definition, then if all my queries are ranged, then I'm pretty hotspots all over the place.
So if you're going to do something that's ranged, you need to take that into consideration with your design as well. So for example, you could say, well, I've got my data access pattern is based on a shop ID and then a user ID and then some time period, and I'm always interested in getting those ranges. Then you could make sure that you would randomize your shop and your user ID so that they could be based on GUID, and then you would have after that your range of dates. But then you take into consideration that you're picking up for those.
Then what about time series then?
Time series.
Yeah, that's the
What you don't want is the time to be the leading part of the key.
Right, but we also want to go balance, right?
Right. So if you sort of look at your time series and you say something like per user, what I'm interested in is time series. Let's say something like per user, and then those users, each of their time series will be on a different.
So
that's how you.
I have to shard by a different concept.
Yeah, correct. Like you do user,
but
and then time stamp.
There are a couple of approaches with time series. You can go wide, or you can go in the depth as well. We do have a paper that describes exactly how to construct this if you're trying to do time series.
If you do time series, if you just Google time series Bigtable, it will get you straight there. There are a few best practices around that.
Cool. We're over time, but let's do a quick demo. So this demo, we took a Kaggle data set. That's the.
But the
fonts?
Yeah, sure.
This is really very small.
We're gonna go here.
Yeah, I can't even tell if it's JavaScript or Python.
Why doesn't my usual? So while I'm thinking about that, I can tell you about the dataset. So the dataset is the bus traffic for New York. It's a Kaggle dataset that we've imported into Bigtable, and then we created a number of queries that you can. So in the dataset, I think the buses have a sensor that I think its frequency is once every minute, or if it's once every 10 minutes. So in this case, we have a row key. You can't see this, and I can't make it bigger, which is basically the bus line. Do you know how to make it bigger?
Presenter mode. If
What?
you go to view and then enter presenter mode. Okay. Where? You don't have it here. Oh wow. It's can you go back? View. Go back to view.
Tool windows. Appearance. Here.
Oh yeah.
Look at this. Bigtable lunch team, ladies and gentlemen. Yeah, so there you see the row key, and we want to look up a specific vehicle for one given hour. It's this method. So one bus in 1 hour, and we would get like, I think it's every 10th minute that the sensor reports its location. So, and then we print the lat long pairs.
So it looks like a row key is a combination of a bunch of fields.
Yes, exactly. So that's a very common way to construct your row key.
And in which cases you would say you would use hashing? You will take that and hash it up, and that kind of provides you uniformity, right?
If there's some other thing that creates the uniqueness for the okay.
But then to call up that row, I need to take the value and hash it.
You need to figure out which key you
So, for example, if you have let's say in the system that's writing has a customer ID and that there is some like sequential in that, you could take that customer ID, you could hash it, and then you could put the customer ID after that, so you could prefix it with the hash of itself, so you can randomize over that space. But there are a ton of different key strategies. We also have a paper on that, so if you Google Bigtable and key design, you'll find some papers about how to choose.
So let's run this query, and we will get lat long pairs back, and then we will take those lat long pairs that we see here, and we will put them into MapMaker. Import data. I've already done this, so. And here you see the location of the bus M86 or whatever it was during this hour. So This is a code lab that anyone can go in and do. We go through everything from point lookups to short range scans to filters and what do we call it? Multiple range scans. Cool. That was the Bigtable stuff. What do we have? Let's see. Let's see what we have.
Regarding time series, you can also use OpenPSDB over Bigtable. We have some documentation around that. So then that takes care of figuring out what's how to use the keys the same way. You can also use there are all sorts of frameworks that you can use on top of Bigtable.
So Graph was mentioned earlier. You could use Yanis, for example, on top of Bigtable.
GeoMesa for geospatial queries. There's support in TensorFlow these days for training machine learning models on data that resides in Bigtable. Yeah.
So how much is the current version of Bigtable different than the one described in the original Bigtable?
So we have the internal and the external Bigtable. I would say that the biggest difference is that in the internal one we have something called locality groups, and that we don't have in the external one. Apart from that, I would say that they are pretty similar.
At some point you showed some SQL regarding.
Yeah, no. It was just a way to translate the API into a SQL interface. But we actually have something called federated queries. Is that still a thing? Yeah. So you can.
It's very hard to persuade any organization like financial to put data in something that is not SQL.
Yeah, no, but like federated queries is something that it's a feature in BigQuery, and it lets you ask SQL queries over different storage engines. So BigQuery, of course, have its own storage engine, which is super fast, but you can also apply that to Bigtable. So you can write SQL queries over Bigtable data that is stored in Bigtable. It's not super fast, but it's a great way for like copying data from Bigtable into BigQuery if you want to do more ad hoc analysis. I would say that these two products, although many people mix them up, and I guess we have ourselves to blame since the names are pretty similar, but they are very complementary.
Well, let's say I have two applications, right? And one has a set of data and another has a set of data. And I would create two collections. What do you call them? The column qualifiers?
Tablets.
And when you group them, like in a
column families, yeah.
Column families, yeah. So for one application, I'll have 3 column families, and for another, we'll have, let's say, 5 column families. Mm-hmm. They will reside on the same row, right? All through.
If it's in the same table, yes.
So, if I was.
But also think about it that it is sparse. So if you don't put anything there, it doesn't matter.
It doesn't use any space.
No.
Well, what about key values? One application maybe, when you do key values, it's like creating an index. You really need to think not about the data, but about the usage. All right? So one application may have completely one patterns of querying the data, whatever they do with it, and another one completely different. I mean, how do I?
In that case, you would use 2 different instances.
Yeah, put it in different tables.
It's not.
So I can create more than one table?
Yes, you can create 1,000 tables per
You can create different Bigtable instances and maybe one different collection.
But that's in separate clusters, right?
No, you don't have to read the separate.
That's not
Give
true.
me collections, so you can choose. A collection is not a table in a database. You can have
Yeah, it's
more
a
than one
collection of-
collection for Bigtable instance.
Well, how many instances can I have on a node?
Okay, that's
Instances are bigger than nodes, but
Or okay, on Colossus, how many?
Well, as many as you pay for.
Yeah, but how would we map it to nodes that I would call nodes of this big table?
So node is a different concept. A node, basically, you can have you need a minimum amount of nodes to address the amount of storage that you want, but you can add additional nodes in order to get more throughput. So if you like Daniel
It's a
showed,
compute then.
sorry.
Yes.
Yeah.
Yes. An instance is what you go and you create. An instance can have different clusters. Okay. Each cluster has nodes and storage.
So each cluster is an instance.
No, an instance can have many clusters. Instance is the top level.
Okay.
So if I want another instance, I will need to get at least another cluster.
Yes. But one instance can have many clusters.
Yeah.
And also many tables.
And many tables.
Yeah.
So I think what you're referring to in your original query is that you probably want many tables that you query. Maybe the data is duplicate, but it's.
But if the data has nothing to do with each other.
Yeah, exactly. Then you put it in different tables.
You can put it in different tables or different instances.
But you know how it is. It has nothing to do with each other for these many years, and then all of a sudden people want to look at it together. So can you do some queries across instances?
You have to do it in the application layer.
Yeah.
You have to query from here, query from here.
But you have to stitch it together yourself.
Yeah.
So I'm curious about the data model of Bigtable. So you have this fairly weird thing, right, where the rows are wide, right, that you can have arbitrarily many columns.
Mm-hmm.
So do you see people use this thing? And if so, how do people use this ability?
Which?
Well,
the wide column.
yeah.
Well, think about
More tall and narrow, I would say.
Sorry?
But I don't know. Maybe.
Oh.
I mean, it depends on the use cases. Let's say you track like user activity sometimes in some,
Okay.
so for some customers it can get very, very wide. Amount of fields that you can store per.
Just because I'm recording many types of activity for users.
You just have a lot of evidence or a lot of cells per data entry. Per click that you did, I capture 50,000 or 200 properties around it.
Same thing for like IoT. Like I have a sensor at my oil rig, and over time these sensors collect more and more different pieces of data at a given time span.
So
it's like
in that sort of workflow, how trivial is it to add a new column or?
There is no schema. You can you just put
But
it.
then you have families and columns, and you can
So-
just like you don't have to create that ahead of time.
Right.
Okay.
You don't have to create ahead of time. You can add those as your system evolves. So let's say you have different instruments you're collecting, like you have devices, and you're collecting 5 metrics, and then suddenly you add a new set of metrics. You can add a new column family, you can add new columns. I mean, that's a column family is just a logical grouping.
Yeah. Crucially, in SSD this doesn't matter. So you can choose SSD or HDD when you're storing your data. For SSD it doesn't matter as much anymore, but you can use column families and different columns to group. You don't have to read the entire row.
So it's more of a skin for access
Exactly.
than actual sort of.
Yeah, but you can query. You don't have to query the entire row. You can just say the columns you want.
Okay. So let's say I'm interested in figuring out what data and what is based on let's say a knowledge data. So when we store data, sometimes we store 2 timestamps. One of them is when the date actually applies and when we actually acquire that knowledge. What would be the best way to use a Bigtable? So let's say I want to run 2 scenarios. One of them is if I had known this 10 years ago, what's the result? And run it as if it's history.
You probably wouldn't want to put both dates in the key.
Right. Yeah, we might want to take this one offline.
Okay.
Would that platform be good for like application like YouTube or service? I'm kind of talking about binary data stuff. Would that be?
Well, you can store binary data there if you want to, and I guess we internally have used it for Google Earth and the tiles at least.
Yeah, but Google Earth is more numbers than.
I mean, if you're talking about the video data, that's more, the likely candidate would be Google Cloud Storage, which is the Loft storage. That's where these things are the likely.
But I can have a key and a value being blob.
Metadata. That's a very.
Probably have the metadata in Bigtable.
Right. That's a very common use case. You have metadata in your data store, and you have the actual files in binaries somewhere else, like cloud storage.
This is a quick question.
Unless
so
you want
I
to.
understand that the query access patterns and the capabilities are quite different between Cloudspinner and Bigtable, but imagine you have the same kind of regional replication deployment for point reads and point writes on single rows of the same size. Do you have a rule of thumb for the cost differential?
That's a good question.
So, if you think of they're quite different. So Spanner will give you transactional consistency over multiple rows.
Yeah.
So if you want strong consistency over multiple rows, think about Spanner, but you are going to take the latency hit on that.
Forgetting the latency profile, it's more a question of cost.
Of money.
Money.
Spanner is a cost calculator, right?
They both have cost. You can calculate cost of both.
Alright, I'll just go online. I was just wondering if you guys had it back the envelope that you work from. That's
It really depends on the topology also of what you're trying to achieve.
And what is it you said that I would want to store blob files?
Cloud storage.
Okay.
Cloud storage, right?
Cloud storage.
Well, can I run ML on cloud storage?
Sure.
Or I better put it in here and run.
I mean, if you're running TensorFlow on Cloud Machine Learning Engine, there's a connector for storing your input data on cloud storage, and
so
then
I have 1 hour pieces of video.
Yeah.
From CCTV
Yeah,
camera.
you can.
And I want to find a face of somebody.
Yeah.
Yes. Through all of them.
So,
Well. Are you talking about like an online thing now?
No, in batch.
In batch, okay. But then. No, but like you could do stuff like if you're talking about like reinforcement learning, would be a great use case for Bigtable, where you actually have to have super low latency in order to take decisions. That would then Bigtable would be a much better candidate than cloud storage, for instance.
Well, for neural networks, you do need
Yeah.
low latency.
Yeah. Cool. More questions?
TensorFlow connects to
Sorry?
TensorFlow connects to this.
Yes.
Direct integration.
Yes. Cool. Thank you.
Alright guys, we got the raffle giveaway, don't go nowhere.
Because I hope you don't go to no, that's not mine. The thingy.
The other one, I don't know where it is.
Guys, you want to win something or not? Come on. This one. Alright, everyone has their card in here, right? Yeah. Alright. For an awesome Google Home Hub. Let's see. I'm gonna say. Can you mix it all up? Wait, you say. You need to reach in. Look that way, reach in, pull out a card. Look that way, reach in, pull out a card. Well, no, look that way. Look the other way. Anyway, that way, pull out a card. Alright, read it out loud. Lever Finney? No, okay. Next. Alright, come on up. Alright, our speakers students are here for one-on-one questions, feel free to come on up now and ask. Thank you all for coming.